Hello students, in this video we will study about Bohr's postulates. In the last video we studied about J.J. Thomson's atom model, which also is called plum pudding model or watermelon model, and then we studied about Rutherford's atom model with the help of a gold foil experiment. We also found that it's also known as a planetary atom model, and where the electrons were moved out of the nucleus, but again that could not explain the line spectrum, and also it cannot be a stable atom. So now Bohr, he introduced importantly certain changes in that. So what is the Bohr's postulate is about? The first I want to tell you, already we know that the nucleus consists of positive nucleus, right? So still neutrons were not discovered, so it consists of only positive nucleus. So what did Bohr do? First he said that the electrons which are revolving around the nucleus, the electrons revolving around the nucleus can be only in permitted orbits, and the permitted orbits are non-radiating. Okay, so the first postulate is non-radiating orbits. Okay, and these are called permitted orbits. Okay, if this is so, then how are we seeing line spectrum? How the line spectrum is coming? Yes, he got an answer for that. He said when an electron jumps from one energy level to another energy level, okay, energy level, it's not really an actual path, okay, it is just an imaginary circle I have drawn, but electron is revolving in its own way. Now if it creates another energy level and if it goes to the higher energy level, how can the electron go to the higher energy level? It will absorb energy, and it will absorb energy in terms of h nu. H nu is Planck's quantum equation, right? Planck's quantum theory. Now, if it is from a lower orbit to a higher orbit, it will absorb energy. Yes, equally if it can go to a higher orbit, it also can come back to the lower orbit. So when it is from higher orbit comes to a lower orbit, it will emit energy which is also in terms of h nu. What is the meaning of being in terms of h nu? You know E is equal to h nu, that is equal to hc upon lambda, and here wavelength, that's what the spectral lines are about. It represents wavelength. So it could explain it. Yeah. So the second postulate is when the electron jumps from a higher energy level to a lower energy level, then it will emit energy, and when it is moving from a lower energy level to a higher energy level, it will absorb energy. Okay, so this is the second point. It's a classic idea. Yes, it is all how the development of atomic physics is taking place, because we cannot see the atom, but you are creating a theory and it has to withstand the judgment of the experiment, and these are all experimentally verified. And beyond Bohr's atom theory, which is in our 12th standard, you will also learn about Sommerfield's atom model, right? That is a little higher level in college physics you will learn. Okay, now this is done. Now third important point is, whenever the electron is revolving around in a circular path, it should possess angular momentum. Yes, see, this is about angular momentum. Okay, now when we talk about angular momentum, what is that? L is the symbol. Angular momentum is given by mv into r. You know, the linear momentum is m into v, and you give the symbol p, and here mvr you give the symbol L. He said that the angular momentum will be an integral multiple of h upon 2 pi. Yes, and this is the next thing. This is called Bohr's quantization condition. This is referred to as Bohr's quantization condition. Okay, so what is the Bohr's quantization condition? It talks about angular momentum of the electron which is in the orbit, that is mvr is equal to nh upon 2 pi. And this one which you are talking about, this you can write it as the fourth equation. The change in energy is equal to h change in frequency. This is called Einstein's frequency relationship, which is just a general term. Einstein's energy, not energy, frequency condition. Okay, this is called Einstein's. Also you can write that is equal to h c upon delta lambda. Very often we use wavelength, and sometimes we use in problems of frequency, and this is called Einstein's frequency condition. So in this we are seeing Bohr's postulate. 1, electrons revolve around in non-radiating orbits which are called permitted orbits. 2, when electron jumps from a higher level to lower level, it emits energy. When it rises from a lower level to a higher level, it absorbs energy to go to the higher level, right? And then angular momentum mvr is an integral multiple of h upon 2 pi, and that is called Bohr's quantization condition. And fourth one is the change in frequency is equal to h change in, that is what we are talking, E is equal to h nu, which is from Planck's quantum equation, and that is called Einstein's frequency condition. In this continuity of it, I wanted to do a small derivation here, yeah, and next we will be doing about radius of the Bohr's theory, Bohr's atom model. Okay, before going to that, I wanted to explain a small point. There is a logic in it, yeah. See, we say that angular momentum is equal to mvr, which is equal to nh upon 2 pi. Fine. I am going to make a small rearrangement. How? See, I have here 2 pi and I have r. So I write 2 pi r is equal to nh upon m into v. I bring it here m into v. I will write this as 2 pi r is equal to n of h upon mv. Okay. And what is h upon mv? In the previous chapter, we learnt about de Broglie wave equation, that is 2 pi r is equal to n, that is nothing but lambda. This is a very important equation. You should keep it in mind. Why? Why? Because it explains about wave nature of particle. Yes, the electrons are revolving around. Fine, it's good. We know that already. Yes. Now what is the relationship? How is it going to revolve? That is what is given by this equation. What is 2 pi r? 2 pi r is the circumference of the circle. Okay, 2 pi r is the circumference of a circle. So this is the circumference of a circle, that is equal to n times lambda. It will be a whole number. So if I say I start a wave here, if it is having wave theory, yes, I am just going to draw like this. Okay, I am trying my level best. So you see here, 1 wave, 2 wave, 3 waves, 4 waves and 5 waves. It is an integral multiple. That's why this formula is very important, because it explains to you that the circumference consists of n number of wavelength. So this is one of the most important conclusions from Bohr's postulate. Okay, so this is a particular learning which you have to do. And the next discussion is going to be about radius of hydrogen atom. Radius of the hydrogen atom. Okay. How should we go about it? And let me do it. Yes. Yes. Let me begin it. This is